All right, let's talk about dilution. It's going to be a short one. So, dilution is basically you're taking a solution, you're adding more solute or solvent, excuse me, which is usually water, to make a weaker solution. You're lowering the concentration. Okay, so you increase the volume, you decrease the concentration. That's a very simple mathematical formula, and that's that M1V1 equals M2V2. So the initial molarity. So the initial molarity times the initial volume is equal to the final molarity times the final volume. So given three of these things, you can find the fourth. The units need to be the same on both sides, but unlike when we're doing calculations with molarity, most calculations with molarity, molarity is always going to be in moles per liter. So that doesn't really matter. But the volume could be in liters, it could be in milliliters, it could be in microliters, as long as it's the same on both sides. Okay, so if I were to ask what volume of 3.4 molar HCl is needed to make 500 milliliters of a 1.05 molar solution? Well, the most important thing here is to identify what numbers do I have. So the larger molarity, the higher molarity is always going to be your M1. And then in this case, it's saying we're make 500 milliliters, so that's our V2. And then 1.05 molar, the smaller concentration, that's going to be our M2. So if M1V1 equals M2V2, then rearranging that to solve, we're solving for V1. V1 is equal to M2V2 over M1. So I just, move this down here. So 1.05 molar, that's my M2. V2 is 500 milliliters. Divide by 3.4 molar, molarity cancels, and you get your answer in milliliters. So let's do some practice. What is the molarity of a solution made from diluting 130 milliliters of a 5 molar solution of H2SO4 to 750 milliliters? Okay, so remember, M1V1 equals M2V2. So I'm diluting 130 milliliters, so that's my V1, and my V1 is of a 5 molar solution, so that's my M1. And I'm diluting it so the larger volume is always the second volume, that's my V2. Okay, so I'm solving for M2. So M2 is equal to M1V1 over V2. So 130 times 5 divided by divided by 750. Milliliters cancels. You get molar. And that's equal to 0.87 molar. 230 milliliters of a solution is diluted to 1.3 liters. The final molarity is measured to be 0.42 molar. What was the initial molarity? Okay, so here's my V1. Here's my V2. Final molarity is 0.42, so that's my M2. So I'm solving for M1, which is equal to M2V2 over V1. So in this case, it's equal to 0.42 molar times, now we have to be careful here, this is in liters, this is in milliliters. So they have to be the same unit, it doesn't matter which one. So I'm just going to leave this in liters since I'm writing it first. So 1.3 liters divided by 0.23 liters. So liters cancels, right? So I could do 1,300 milliliters over 230 milliliters. That would work too. And that comes out to 2.37 molar. Finally, if 20 milliliters of an 8 molar solution are diluted to a final concentration of 0.35 molar, what is the final volume? Okay, so now we're solving for V2, which is M1V1 over M2. So I've got 20 mils, times 8 molar divided by 0.35 molar. You get 457 mils. Okay, so dilution, pretty straightforward. The most important thing is identifying, looking at the word problem, and because you always get 3, identifying, okay, here are the 3 I have. This is the one I'm looking for. So just read the question carefully, and the math is very straightforward.